Hi, I'm Bruno. I'm going to talk about deployment automation for an AWS serverless project. Quick words about where I work. I work at Futurize. Futurize is a company that does software engineering and innovation consultancy with offices all over Europe. We like to say that we have Nordic roots, but a global mindset. The company was founded in Helsinki, which is where I live. And we have been having like year over year a 30% growth. Quick words about me. I'm a principal architect and technology advisor at Futurize. I focus in areas like DevOps, cloud, security, and AI, and I know that they are very, very broad, but so is what we do at Futurize. We work with a lot of different type of projects, from biometrics to cloud and consulting in that. I'm a Portuguese native. I guess you kind of got that from my non-British accent. I live in Helsinki for the past 7 years, and I really enjoy coffee, which you don't need to know that, but I'm going to give a personal touch to the presentation. And I like to do indoor climbing and traveling and reading. So when you think about deployment automation, you usually think about application deployment or infrastructure deployment or both. With cloud, it becomes more and more common, the term infrastructure as code, which is kind of new because when we had on-premise systems, you couldn't really easily do infrastructure as code. And with infrastructure as code, you gain a lot of benefits. One is that obviously you can version your code, so you can version your infrastructure. You can have it in Git, for instance. And that allows you to trace who did what and why, if you fill the Git commit comments. Also, it allows you to repeat your infrastructure, meaning that you can have the same infrastructure, you can have it in testing, development, in production. And that's kind of like common concepts. But I just want us to start on the same level. And I'm going to talk mainly about infrastructure automation, but also touching a bit the application side. And I know it's kind of funny that the first slide is a Google Cloud quote in an AWS summit, but they actually put this quite nicely, why we should automate our infrastructure. And it's a lot about that you want to reproduce, you want to redeploy. And they mentioned something about complex systems and huge architecture. And that brings me maybe to a point, which is maybe an unpopular opinion, that not everything should be or needs to be automated. And I know it's fairly common to hear that, automate everything. Those words everyone keeps repeating them. But in real life, maybe you don't need. Meaning that, to me personally, it's a bit unreal that people will spend 1 day, 1 week, trying to build automation for something that they only need to do once a year or twice a year. Meaning that my personal rule about automation is that automate everything that impacts directly the users of your service. Meaning that if your service crashes and burns, how can you bring them up? How can you bring it up as quickly as possible? And you focus first on that. Everything else on tooling, it's nice if you can automate it quickly, but measure the pros and cons of that. Are you going to spend time automating something that you will only touch in a year when maybe all the APIs that you are interacting already changed? So think about that. Now, I know this might shock you guys. I apologize for that, but when I was thinking about automation, I was thinking about the demo app that I could build. And I didn't want to make this hello world type of applications because that's kind of pointless to compare. I wanted to make something that was, in a way, would be very similar to how you'll have in the real life. So I built a website, and I know that voting is apparently something somewhat in the news nowadays. So I made a small website that you can use to vote. And this site is actually live, and you can actually visit with your phone, and you can actually use it if you want. The domain name doesn't mean really anything. I just created it randomly in AWS. I just wanted to use a custom domain because you know very well that in real life you will not expose maybe API gateway, amazon.aws.com and things like that. You probably want to bring your own custom domain. So I actually wanted to use that too. And it's a really simple app. Simple website, static website, 2 options, 2 buttons, and then there's an API that processes that and stores that result. That's pretty much what it does. But I wanted to build it without any server. And to do that, I made a very simple architecture. And this probably is very familiar to you. But basically, the static website, I'm hosting in S3. And I'm creating in Route 53, I'm creating an alias for that. And that's all you need to create the website. Now, you might have noticed from the screenshot in the slide before that there was no SSL. And the reason for that is that I didn't want to use CloudFront because it takes a lot of time to bring it up and turn it down. And that was the only reason. But in the API gateway and Lambda to process the request, I'm actually using a certificate and SSL. But you can actually, all of the code that I will show is actually on my GitHub. So you can actually go there and check it out. And basically, if we focus on the orange part, that's the part that I created with CloudFormation, SAM, and Terraform. So the same application, I wanted to test how does this look like from a developer point of view if I want to build this up using the 3 tools. And for collecting the results and creating a quick visualization, I'm using Athena with QuickSight, which is a really, really powerful combo if you never used it. Athena, actually some presentations actually touch that during the morning. Athena is really, really nice because it allows you to, make SQL-like queries on top of the data that you have in S3. And basically, you only need to specify to create a table in Athena saying that, hey, these are my fields, this is the bucket where the data is, and then you can do SQL-like queries on top of that. And then QuickSight is for analytics and dashboards, visualizations, and interacts directly with Athena. So you can just say like, hey, this is the Athena table that I just created, and I want to visualize this. So it's pretty straightforward. I didn't create the automation for that. There was actually good examples from Amazon, and I've actually used that to create it. They are listed as reference in my Git repo. So you can also check that out. So CloudFormation, when you think about infrastructure as a code, that's the recommended tool in AWS. That is the tool that AWS promotes. And that's, if you only use AWS services, that's the tool that you have at your disposal. Now, CloudFormation has been around for quite many years. And basically, it allows you to write either in JSON or in YAML the code, how does your infrastructure will look like. And it's really, really powerful because it pretty much covers all the AWS services. Not all, but almost. And it kind of looks like this. And this is a real example. So on the right side, you have the YAML file that for the S3 bucket. And it's divided in mainly 3 sections. And only one of those sections is actually mandatory, which is the resources. The first one is the parameters, and that's optional. You can picture as variables that you can pass. And below you have the outputs, is that if you want to output something from that stack and use it maybe for yourself or to reuse it in other stacks, that's how you will expose it. And it uses this in the resources. You basically are listing all the resources that you need to create. It's not completely straightforward how you do that. You actually need to check the documentation quite a bit because there's a lot of different things. Even for the same, if you picture API gateway is not really a single resource, it's actually a set of multiple resources. So you actually, it's not that trivial to create, but it's not that bad to do it. The way that you use CloudFormation after you write your template is that you basically using the AWS CLI, you can use AWS CloudFormation create stack, point to that file, and it creates your infrastructure. Also, very easily, you can destroy the stack by using delete stack. Now, this doesn't really take care of deploying the application, only the infrastructure. So in the case of the website, you still need to, the static website, you need to copy it to S3 because it's hosted there. And in case of the Lambda, I'm uploading the Lambda to an S3 bucket that my CloudFormation will pick it up. But it brings some advantages, for instance, when you want to visualize what was created and what type of events, you can actually go to AWS console and you can actually list it there. You can actually, if you don't want to use even the CLI to deploy or to terminate, you can use it directly from there using the same template. And this gives you a nice way to have a very consistent deployment across multiple accounts, multiple services. But it brings, there's some drawbacks, and especially when you think about serverless applications, it can be very daunting. And Amazon created something called SAM. And SAM stands for Serverless Application Model, and it extends CloudFormation. So if you are actually used to do CloudFormation, you can actually immediately start using SAM because it's very, very straightforward to use it. It uses the same YAML style of templates, but by its own definition, it only covers a couple of services. And you can actually see that it's very focused on API Gateway, Lambda, and Dynamo. Now, this is actually how it will look like. So I started by making my application with CloudFormation, and then I started to do it with SAM after that. So how does it look like? Well, on the left, okay, in the middle section where you have CloudFormation and SAM, that snippet of code, which is part of the resources in CloudFormation, you actually end up being transformed to only those lines of code in SAM. So it actually decreased quite a bit the code base, quite sizable. Everything else looked very similar. You also have parameters. You had exactly the same type of style, only the resources changed. Now, you can actually see now on the left side that there was a couple of things that didn't change. So I was actually expecting, when I used SAM for the first time, I was actually expecting that it will cover pretty much everything that I need to do in API Gateway. But actually, that was not the case, because this was no simple hello world. I was actually using API keys. I enabled cores, enabled custom domains, and it didn't really cover everything. Actually, I end up having to use some of the existing CloudFormation, original CloudFormation templates to cover it up, especially on the API key, usage plan, domain names. But other than that, it actually behaved quite nicely, and it still reduced quite a lot of the code. Now, one thing also to take notice is that, for instance, on the S3 buckets, I actually had to reuse the existing stack that I had for CloudFormation because the serverless SAM doesn't really cover those type of resources. But it covered quite like half of them. So you can actually see the ones that were transformed and the ones that didn't stay the same. Now, SAM is also a bit new, well, few years. And there's actually a lot of active work on that. So I actually started to check, like, why couldn't I do API keys with SAM? Wasn't that what was supposed to do? Wasn't that the promise? And in fact, there is actually plans to do so. And there's actually, in GitHub, there's actually a lot of comments about that, and there's active work on that. So I think that, you know, in a couple of months, maybe, or a couple of years, this code base actually could be reduced even more, at least on the API level, API gateway level. Now, the way that you use SAM, in addition to the changes in the template, obviously, is that it brings some additional features that are actually quite nice. They're very focused on Lambda, but still quite nice. One is that, well, you need to install a client tool called SAM. And actually, when you run SAM the first time, and you can actually see on the left side, there's a lot of commands at your disposal. And one of them is quite interesting, which is that allows you to do local testing. So you can actually test your Lambda locally. And if you ever develop with Lambda, you know that's can be a bit of a pain in the ass to troubleshoot when you don't have that type of functionality. And so you can invoke your Lambda, and you can actually run it in your local environment. It creates like an API gateway to you, and you can use it from that. Then there is, in addition, before you actually use AWS CloudFormation create stack, you actually need to use a command which is SAM package. And what that command does is that it essentially, if zips the Lambda repository, puts it in an S3, and also changes a bit the template that you just created, and just say like, hey, you can find the Lambda code in this URI. And that actually is quite nice. You don't really need to take care of the application deployment if you are thinking just in Lambda. However, which was my case, I also had to deploy the application, which was a static website, and in that case, I had to copy over to S3 manually. Now, also, one kind of extra advantage that SAM gives you is this serverless application repository, where you can actually go and reuse some of the applications that are there. Intentionally, I didn't want to reuse any of these applications, because I wanted to have the experience of doing it without reusing someone else. I wanted to use exactly what Amazon provided, but you can reuse things that other people publish there. And that should actually also decrease a bit your code base. Now, when you think about infrastructure deployment, Terraform is one of those tools that come to your mind if you have been comparing those tools. And Terraform is not an AWS tool. It's actually provided by a company called HashiCorp. And HashiCorp, you might know them. They provide things like Consul, Packer, and some of the tools that you might be already using. And the idea of infrastructure as code and for Terraform was that they wanted to be, in a way, agnostic. They didn't want to build something just for AWS. They want actually to build something that you could use with multiple clouds. Now, there is, though, one small thing on that, which is that even though a Terraform template or Terraform supports multiple clouds, it doesn't mean that you can use your exact template with multiple clouds, meaning that you can use this use the same language to describe resources in different clouds. But you cannot say like, I have this instance and now I want AWS or now I want Google Cloud. No, you cannot do that, because as you can see on the right side, you are actually specifying on the resource, you are specifying that is an AWS S3 bucket and not a Google Cloud storage. But they provide this multiple provisioners and multiple modules to abstract this. It's open source, but they also have an enterprise version that you can pay if you want support. One of the biggest advantages of Terraform is that you can use in the same template, you can describe things from different environments. So even though you cannot use the same piece of code, the same resource to different clouds, you can have one resource that say, I want to create an Amazon S3 bucket, but I also want to create a Google Cloud Storage bucket. So, and you can use that in the same file. And that is kind of interesting and allows you different possibilities that with CloudFormation you cannot. So if you're using multi-cloud, and not just multi-cloud, but for instance, if you're using Cloudflare, you can also describe it here directly. And while with CloudFormation, you will probably need some kind of Lambda to abstract that. It also provides this module registry, very similar to SAM, that you can reuse other people's modules, or you can actually use HashiCorp certified modules. I intentionally didn't use any of that. I wanted to use just the bare minimal. I didn't want to reuse anyone's modules. I wanted to see the experience of doing it from scratch. But I still ended up with a code base that was still smaller than CloudFormation and a bit, in a way, similar to SAM. The language is not JSON. It's actually HCL, HashiCorp language. But you might be fooled at the first time thinking that that language is JSON, because it's very, very similar. So if you are used to work with JSON, you will think that it's very identical. And it also obeys to the same type of logic that CloudFormation has in the sense of, this is how I describe my resources, this is my variables, my parameters, and I also have outputs. So it obeys to the same type of logic. Now, the way that you use it is that you start by initializing Terraform. And when you initialize Terraform, you are basically downloading from the internet any kind of providers that your code might need, in this case, AWS. You only need to do this when you change the type of providers that you use. You do it once. And then after that, to deploy your application, you only need to do two things. One is plan, and the other is apply. So, and this is a concept that actually neither SAM or CloudFormation really have, which is that they abstract the planning from the execution, meaning that you start by doing Terraform plan, and when you do that, it will check against your state file and against the AWS resources that are deployed, did something changed? Will I actually need to do something? And by doing that, without actually executing that action of creating or destroying resources, you actually end up causing a bit of like some bugs in your code. And that is actually quite nice because it doesn't really, interrupt that much your operations. And then after you run Terraform plan, you can just run Terraform apply. And when you do apply, basically it will execute that plan. And it will actually provision or destroy the resources that you have. Now, there's also a couple more benefits. One is that you can make it iterative, meaning that you can actually, if you don't specify the values of the variables, it will ask you. And that's actually quite nice. With CloudFormation or with SAM, you actually need to, if you don't define, it will fail. Meaning if you don't define the parameters, either by the arguments or in the code, it will actually fail. And Terraform will make it interactive. It will ask you. And the other kind of nice thing, well, it's a bit, I don't know if it's nice or not, but it allows you to generate this resource graph. Some people like it. In real life, I actually never saw anyone taking much advantage of it. But the option is there. And it basically generates this dot file that you then can convert to SVG. And this application looks something monstrous like that no one can really read. But it's described as a type of SVG type of file. So it's described as a language, so you can actually visualize it in different ways. And when you don't need your application or infrastructure anymore, you can just destroy it like you do with CloudFormation or SAM. So, in a way, taking all of those three tools, there's a couple of pros, cons, and things that I'm not sure. One is that, well, CloudFormation is AWS native, and it brings some advantage being AWS supported tool, meaning that AWS, you can actually use AWS customer support to request for help. And it's a service that is free. Actually, Amazon doesn't really charge you anything for it. You can build your templates with JSON or YAML. So you actually don't need to learn HCL in case of HashiCorp, Terraform. And as a con is that I find it actually very hard to troubleshoot. It's not so straightforward to know why did something fail. The templates are not so easy or pleasant to write, and the documentation is, in my view, is a bit poor in the sense that for beginners, you find that you struggle a bit to engage in starting to use CloudFormation compared with, for instance, Terraform. But if you are an advanced user, you can actually find pretty much all the options from the documentation. Now, SAM brings some really interesting capabilities to CloudFormation. One of the things that I liked is that the ability to troubleshoot, to test your lambdas locally, which also brings the easier packaging, but it only really covers some AWS resources. So if your architecture is very Lambda API gateway centric, it makes perfect sense for you to use it. But if you are using, for instance, S3 or other services, you actually don't get much benefit from it. But you can mix and match, and it's kind of very easy to mix and match using things with SAM and with usual CloudFormation. You actually don't really notice anything except the name of the resource or the type of the resource that change. And in a way, it's quite transparent to use. Now, Terraform brings some interesting options, especially if you are using more than one cloud. If you are using, for instance, Google Cloud and AWS, or Google Cloud Azure and AWS, or if you are using resources like Cloudflare as part of your architecture. But it's not AWS native, and the support is paid. And there's a trade-off here. Obviously, it used to be that with Terraform, some of the new features from AWS were not there straight away. They were not so quick to introduce the new features as CloudFormation was. But actually in the past months, I think that they are actually quite an okay level. And they actually come up pretty quickly, also because Terraform is gaining a lot of popularity. The resource graphs is something that I personally don't find that appealing, but some people really like that. And there is one issue with Terraform that I actually didn't mention so far, which is this remote state file. So when we are using CloudFormation or SAM, the state of your resources is kept neatly under CloudFormation. You go to AWS CloudFormation and you can actually find your stack, what's the state of that stack, what's the status of each of the resources. But when you are using Terraform, what ends up happening is that you need to store that state in a file. Now, you can either store that particular file in your local disk, or better yet, you can use a remote backend, meaning that you can store it somewhere else, which is usually S3. Now, the problem is that if by accident or intentionally that file is deleted, basically you have no way to actually have the state of the thing. So you will have resources that are deployed, and Terraform will not really recover well from not having that file. And it's a bit of a chicken and an egg, meaning that in order to store that file also in a S3 bucket, you need to first have an S3 bucket. So you can actually, that first initially S3 bucket, you need to create it manually, which sounds a bit counterintuitive. But other than that, I really like Terraform in general, and SAM as well. And that's all I have to say. Thank you. If you have any questions, feel free to bring them.
Cheers. I just wondered if you'd had a chance to evaluate serverless framework and how you rated it against SAM and Terraform?
I was really hoping someone will make that question. And yes, I did have, but I didn't update the slides with that information. But you actually, if you go to the GitHub repository, you actually also have serverless framework there. So you have exactly this application also written with serverless framework. Now, the thing that I found out, I'm not a really expert on serverless framework. But what I found out by using is that it was really nice that, for instance, API gateway, all the features that I wanted were actually built in there. So I could make the API keys and all of that as part of that. But all the other things like S3 bucket and the Route 53, I had to do with normal CloudFormation. And if you know serverless framework, you know that you can put the CloudFormation in the bottom and you can use that. But I found it a bit weird to actually have CloudFormation mixed with that. I actually had to make some changes to my original CloudFormation to make it work, mainly on the substitution of variables. But other than that, I really like it. One of the things that serverless framework does it also really nice is that it's cloud agnostic in the sense that you can use not just with AWS, but with others. But I found it very centric around Lambda, very Lambda-centric, or very API gateway-centric. Maybe even too much, and I think that maybe that's one of, like, if you are a heavy user of Lambda or function as a service, it probably makes sense to you, or might make sense to you. But if you want something that is more, in a way, open in the sense that is not just about Lambda, but about other resources, I found it a bit weird that you need to mix and match.
Hey, good talk. Do you find when you were comparing CloudFormation with Terraform, there was any difference in the performance of it actually deploying and changing things? Did you see any differences there?
I wouldn't say performance-wise, but one thing that was very visible is that in CloudFormation, especially with API Gateway, I had to put a lot of depends on that. With Terraform, I didn't have so much trouble. So it actually, internally, it knew that you had to wait for certain resources to be created. And I think that was a bit nice. I still had to use in 2 situations, but it was a lot less than with CloudFormation. So it was similar time to deploy.
Thank you very much for this good talk. I'm glad that people comparing still CloudFormation and Terraform. But I think you didn't actually go in enough details about Terraform. So I can tell that same situation as with CloudFormation, you have to bootstrap something. And the way how people bootstrap Terraform before they start using S3 bucket is by using different Lambda functions which will create some resources which other users of Terraform can use. So there is no need to think about this as chicken and egg problem. Okay,
but with CloudFormation, you don't necessarily need to do that?
You still need to give some IAM permissions to something.
IAM, yes, correct.
You still have to create some resources.
Yeah. But I will actually be happy to discuss with you about the Lambda part and how could you do that with Terraform.
Yeah, we can do this, definitely. But another thing which I think or you didn't say that HCL is actually compatible with JSON. So this means that you can generate JSON file and feed it to Terraform, and they will be working natively. So this means that there are projects where you can generate a JSON file using, let's say, JSONNet or Jinja, whatever you prefer, and then feed it to Terraform, and Terraform will recognize them and create these resources. Same things as people were using historically with CloudFormation when they don't want to write YAML or JSON themselves, they use programming language to do this for them. Yes,
that is correct. Although, like, I personally don't really like, even on CloudFormation, I don't like to write things with JSON. I think it's not really human readable compared with YAML. But you are absolutely correct that yes, you can basically use JSON with Terraform as well. And on purpose, I didn't went that deep because I didn't want to actually use JSON as part of my code. I wanted to use normal HCL, and I didn't want to make something like that.
Yeah. And you can always...
Okay. Let me share it around the room. Thank you. You can carry that on privately.
Yep.
Another question.
Hi. So any of these three or any other out there that might be contemplating the possibility of existing infrastructure that wasn't previously automated, exporting that, saving that, at least acknowledging that perhaps?
So you mean that after something was created manually to generate this?
Correct.
I think there are some tools about that. As far as I know, none are that good. So you actually end up always to do a lot of manual work around whatever is generated from that. I know that, for instance, in Azure, it actually does that natively, meaning that it's not CloudFormation, obviously, but with Azure Resource Manager, actually, there's a feature to generate those, but it's also not that good. So based on my experience, you always end up needing to do the things manually. It's also not that hard to do so. I think that's also the key thing. Sorry? CloudForm. Right. And is it good in your experience? Okay.
There's definitely another session here.
I would be happy to hear someone that actually found it really useful to generate those. But yeah.
Another time. But thank you. So that's been great. Thank you very much.